Hello guys, welcome to Science Learning Gateway. So today I came up with the most requested video for you all, and many comments I have got for this tutorial that ma'am please upload the numericals of the chapter light reflection and refraction. So today in this tutorial we are going to look at the numericals which are given in your NCERT textbook from the chapter light reflection and refraction. Also, along with the numericals, I will tell you all the formulas which are used for solving this numericals. If you have the concept of formula, you can solve any questions. So don't get afraid of the numericals. Attempt the question which you will get in the exam and get full marks. So let's start with the discussion from the numericals, light reflection and refraction. So guys, first of all, I want to give you a brief explanation about the formulas which we will use in this chapter, light reflection and refraction. So first of all, we have mirror also and lens also, right? So first of all, for mirror, we use one of the formula called mirror formula. For mirror, we use one of the formula called mirror formula. And what was the mirror formula? 1 by f is equal to 1 by v plus 1 by u, where f is the focal length, v is the image distance, and u is the object distance. So this formula you will use for mirror. 1 by focal length is equal to 1 by image distance plus 1 by object distance. Next formula which we will use for mirror is focal length f is equal to r by 2, radius of curvature divided by 2. From this you can get one more formula, radius of curvature r is equal to 2 into a focal length. This formula also we have to use in many of the numericals. Focal length f is equal to r by 2 or r is equal to 2 by f. So these are the two formulas which you will use for mirror, and the third formula which we will use for mirror is for magnification, and magnification is denoted with m, right? So magnification m is equal to h dash divided by h. So what is this h dash? H dash is the height of the image and h is the height of the object. So this formula also we will use for mirror. One more formula is there for calculating mirror magnification of your mirror is that minus v by u, minus v by u. V is your image distance and u is the object distance. So these are the formulas which you will use for mirror. Now let's talk about lens. For lens we have lens formula, right? For lens we have the lens formula, that is 1 by f is equal to 1 by v minus 1 by u. F is the focal length, v is the image distance, u is the object distance. Next, for lens, one concept was there about power of the lens. The second formula which you will use over there is power of the lens. It is calculated by, and it is denoted by p, and it is equal to 1 by f, and the focal length should always be in meter. If it is given in centimeter, you have to convert that into meter, and after that only you will calculate the power is equal to 1 by f. And what is the SI unit of this power? It is diopter denoted with the letter D. Now if we will talk about magnification m for lens, then one formula which you will use is m is equal to h dash by h. This is the common formula for both mirror and lens. Height of the image divided by height of the object. Now second formula which you can use for lens is m is equal to v by u, image distance divided by the object distance. Right? Now suppose this magnification, it can be positive, it can be negative, it can be plus minus n. So if magnification is positive, then what we can say about the nature of the image formed? The image formed will be virtual and erect. If the magnification will be positive, then the image formed will be virtual and erect. And if it is negative, and if magnification will be negative, then what we can say? That the image formed will be real and inverted. So one thing is that if the image is positive, the image will be virtual and erect, and if the magnification will be negative, it will be real and inverted. Next. Okay, now this number n, it can be 1, it can be more than 1, it can be less than 1, or it can be equal to 1. So if this n is equal to 1, what we can say? That the size of the image will be equal to size of the object. But if this n is greater than 1 means what we can say? That the image form will be larger in size. That is, enlarged image will be formed. Enlarged image will be formed in this one. But if n is less than 1 means magnification is less than 1, then what we can say? That the image formed will be small in size. That is diminished. Diminished image will be formed. So these are the information which I want to tell you about mirror as well as for lens. Next, the topic of refractive index is also there. Refractive index. So refractive index also we can calculate using 2 or 3 formulas. Suppose two mediums are given, medium 1 and medium 2. So you have to calculate the refractive index of medium 2 with respect to medium 1. So you can use Snell's law, sin I by sin R. This formula also you can use. Either you can use speed of light in the first medium divided by speed of light in the second medium. By this also you can calculate, or either you can calculate by taking the reciprocal 1 divided by 1, 2. Refractive index of the first medium with the second medium. If you know the refractive index of the second medium with respect to 1, you can easily calculate the refractive index of the first medium with respect to second by taking the reciprocal. Okay, now if you want to calculate the refractive index of second medium with respect to 1, you should know the refractive index of the second medium. Then you have to divide it with the refractive index of the first medium, n2 divided by n1. So these were the concept related to your refractive index. Now next, for sign conventions, many of the children, they get confused in sign conventions. Sign conventions. So this we take as positive, down we take as negative, this side, left side will take negative and right side will take positive. So suppose I have kept my object over there. So this is the distance between from here to here. So we are coming in this direction. So your object distance u should always be negative, whether it is a lens or a mirror. Remember that whatever is given in the question, but you have to take always object distance u as negative. So this point should be in your mind, that whenever you are solving any question, you have to take object distance u as negative, and this is the height of the object. So h is always taken as positive. We are going in the upward direction means positive, so height will be positive and height of the object will be positive and the distance of the object will be negative. This you should remember. Next, one more thing you should remember is that if the focal length is negative, then what type of mirror or lens it is? It is concave. Okay, if it is concave lens or concave mirror. But if focal length is positive, then we can say that the mirror or the lens will be convex in nature. Negative, concave and positive, convex. So now let's start with the numericals of chapter number 10, light reflection and refraction. So the first numerical which is given over there is the radius of curvature of a spherical mirror is 20 centimeter. What is the focal length? So I will suggest you one thing, that whenever numerical is given for you, you will get the numerical in physics, right? So whenever numerical will be given in physics, what you have to do, whatever data is given in the question, you have to write those things first. Suppose in this question, radius of curvature, that is r, is given as 20 centimeter. We'll write that first. After that, we will see that what is asked in the question. What is the focal length? F is equal to how much? That we have to calculate. So just now we have read one formula. Focal length F is equal to R by 2. Radius of curvature divided by 2. That is 20 by 2. 2 ones are 2, 2 tens are 20. So our answer will be 10 centimeter. 10 centimeter, since radius of curvature is given as 20 centimeter. It's given in centimeter. So we have to get focal length also in centimeter. So our answer will be 10 centimeter. Next question. Find the focal length of a convex mirror whose radius of curvature is 32 centimeter. So in this also, radius of curvature is given as 32 centimeter. We have to find the focal length. Same formula we'll use over there also. F is equal to R by 2. 32 divided by 2. 2 ones are 2 16s are 32. Answer will be 16 centimeter. This is your answer over there. Now the third question from here is a concave mirror produces 3 times magnified real image of an object placed at 10 centimeter in front of it. Where is the image located? One concave mirror is there. Okay, it produces what type of image? 3 times magnified image, means 3 times the image is larger than the object. Okay, which is kept at 10 centimeter in front of it, means object distance is given as 10 centimeter in this. Where is the image located? Means we have to find the position of the image. Okay, because the image is a real image, you can see the enlarged and real image they have written. So we have read that whenever magnification is negative, we are getting real and enlarged image that time, right? So magnification is m is negative in this case. So using magnification m, we can find h dash by h. Also, one more formula we have read about lenses. It is a concave mirror. Which formula we have used? We have read minus v by u. This formula we have read, right? So magnification is given as 3 times magnified. So minus 3 we will write. Minus 3 is equal to minus v by u. Minus v by u. Image distance we don't know, but we know about the object distance. It is 10 centimeter. And what I have told you, whether it is a lens or a mirror, we have to take u as negative. So we'll take it as negative, minus 10. Minus 10. Okay. Now what will happen? This minus minus sign will be cancelled out. Minus minus sign will be cancelled out. So we can write minus 3 is equal to v by 10. Now v is equal to minus 3 into 10. Your answer will be minus 30 centimeter. Means the image distance is minus 30 centimeter. Right? Thus the image is located at a distance of 30 centimeter from the mirror on the object side of the mirror. This is our answer. So in this question, magnification is given, m is given as minus 3. Okay? Your object distance, magnification is given as minus 3. Object distance u we have to take as minus 10, because just now we have read, I have told you a formula that object distance is always taken as negative. So we'll take it as minus 10, and what we have to calculate? We have to calculate v. So these are the data which are given to us in the question, and we also know that magnification m is equal to minus v by u. So using this formula we can solve this question. Now let's come to question number 4. Light enters from air to glass. Two mediums are there, air and this is glass. So light will enter from air to glass. Okay, from air to glass it is entering from one medium to other medium. Having refractive index 1.50, means refractive index of this glass is 1.50. It is given in the question. Okay, what is the speed of light in the glass? The speed of light in vacuum is 3 into 10 to the power 8 meter per second. So first of all, they have given us the refractive index of glass, and it is equal to 1.50. And also they have given us the speed of light in vacuum. And C they have given us 3, and also we know that the value of speed of light is 3 into 10 to the power 8 meter per second. Now, what we have to calculate? We have to calculate what is the speed of light in glass. Means we have to find that speed of light in glass. So one formula we have read, that refractive index of the medium is equal to speed of light in air divided by speed of light in vacuum divided by speed of light in the given medium. So over there we have to find the speed of light in glass. Okay, so this value we know, so we can calculate this value using the formula. Speed of light in glass is equal to C, that means speed of light in vacuum divided by refractive index of the glass, 3 into 10 to the power 8 divided by 1.5. You will get the answer as 2 into 10 to the power 8 meter per second. Now let's move towards the next question, question number 5. A convex lens forms a real and inverted image of a needle at a distance of 50 centimeter from it. It is a convex lens. So we have to use lens formula in this case. Uh, Needle inverted image of a needle at a distance of 50 centimeter from it, means image distance they have given as 50 centimeter. Where is the needle placed in front of the convex lens if the image is equal to the size of the object? Also find the power of the lens. We have to find the object distance u. Okay, object distance u we have to find in this question. Image distance is given as 50 centimeter. It is given as 50 centimeter. Object distance u we have to calculate in the question. Now, magnification is also given because they have told us that the image is real and the size of the image and the object is same. That is, it should be equal to 1. And since it is a real image, what we can say that the magnification will be in negative. So magnification is -1. So we can use the formula m is equal to v by u. This is the formula which we can use for lens. So magnification is -1. V is given as 50. U we don't know. Okay. So what we can write? We can write that u is equal to 50 divided by -1. So your answer will be u is equal to -50 centimeter. And also we know that object distance u is always taken as negative. So it is -50 centimeter. Now we have to find the power of the lens also. So for finding power of the lens, we need focal length. So for that we will use the lens formula. 1 by f is equal to 1 by v minus 1 by u. 1 by v minus 1 by u. So 1 by v value is given as 50 and u value is given as -50. So minus minus it will become plus. Minus minus it will become plus. So 50 will take as LCM. 1 plus 1, that is 2 by 50. So 1s are 25s. So 1 by 25 you will get. 1 by 25 is the focal length. So f is equal to how much? F is equal to 25 centimeters. This we have got in centimeter, but we have to convert it into meter. Then only we can find the power of the lens. So how we will convert it into meter? 1 meter is equal to 100 centimeter. So 25 centimeter is equal to 25 divided by 100 we will do. So we can write 0.25 meter. 0.25 meters. Now the formula which we have to use for finding the power of the lens is 1 by focal length. 1 divided by 0.25. This decimal if we'll remove, we can put 2 zeros at the top. 5 20s are 5 5s are 5 1s are 5 4s are. So your answer will be 4 diopter. 4 diopter is the power of the lens. Now the next question, question number 6. Find the power of a concave lens of focal length 2 meter. Concave lens, it is also a lens and focal length is given as 2 meter. So we have to use the lens formula again for finding the power of the lens. So since it is a concave lens, focal length will be in negative. F is equal to -2 meter. For concave, focal length is always negative. For convex mirror or lens, focal length is positive. So we'll use the same formula. Okay, but in this question, image distance, object distance, nothing is given. Okay, so first of all, we have to find the image or the object distance. For that, we will use the formula m is equal to v by u. Magnification we will take as -1. So we can write okay, once again we'll go through this question. We have to find the power of a concave lens. Power we have to find. Focal length is given as 2 meters. Okay, focal length is given as 2 meters. So since it is a concave lens, we have to take focal length as negative, -2 meter. So what is the formula for calculating power? P is equal to 1 by f, 1 by focal length. So 1 divided by -2. 1 by -2. So you can take it as minus 0.25 diopter. This will be your answer for the power of the lens. Now question number 7. An object is placed at a distance of 10 centimeter from a convex mirror of focal length 15 centimeter. Find the position and nature of the image. Since it is a convex mirror. Since it is a convex mirror, and what are the data which are given in the question? Object distance u is given. We have to take it as negative minus 10 centimeter always. Focal length is given as 15 centimeter. Since it is a convex mirror, we will take focal length as positive. And what we have to find in this question? We have to find the image distance v. For that we will use the mirror formula 1 by v plus 1 by u is equal to 1 by f. We will put all the values and ultimately we'll get the answer 6 centimeter. Our image distance is 6 centimeter. Since we are getting image distance as positive, so what will be the nature of the image? The nature of the image will be it will be a virtual image and it will be formed behind the mirror. Magnification also we can calculate. For mirror we use the formula minus v by u minus 6 by minus 30, which will be equal to 1 by 5, means it is less than 1. So magnification is less than 1. So what type of image it will be? It will be a since the magnification is positive, we can say that the image is erect, okay, and it is less than 1, so the size of the image will be smaller than the object. So image is virtual, erect and diminished. This is the nature of the image. Now let's come to question number 8. An object 5 centimeter in length, at a distance of 20 centimeter in front of a convex mirror of radius of curvature 30 centimeter. Find the position of the image, its nature and size. Since it is a question from mirror, convex mirror, so the data which are given over there is height of the object is given as 5 centimeter, which we have to take positive. Object distance u always we will take negative, that is minus 20, and radius of curvature is taken as 30 centimeter. So focal length we can calculate by the formula r by 2, that is 15 centimeter. Again we have to apply the mirror formula. By applying mirror formula, we will get the image distance v as 8.6 centimeter. After that, for finding the nature and size of the image, we should know the magnification, that is minus v by u. So you have to height of the image, height of the object. With that we can relate that, and height of the object we know, height of the image we can calculate, that is 2.2 centimeter. Since the height you are getting as 2.2 centimeter, virtual and erect image will be formed, and it will be formed at a distance of 8.6 centimeter from the mirror, means it is the image distance. Now question number 9. An object of size 7 centimeter. One object is there whose height is 7 centimeter, placed at a distance of 27 centimeter, means u is minus 27. Concave mirror of focal length 18 centimeter. Again we have to take focal length as minus 18, since it is a concave mirror. At what distance from the mirror should a screen be placed? Means we have to find the image distance, that is v, so that a sharp focused image can be obtained. Find the size and the nature of the image. So these are the data which are given in the question. Object distance h is given, image distance u is given, focal length is given. We have to find the image distance and size of the image, that is h dash. So we have to apply the mirror formula. 1 by v is equal to 1 by u plus 1 by f is equal to 1 by v plus 1 by u. This formula we have to use, the mirror formula, and by applying the mirror formula you will get the answer of the image as minus 54 centimeter. Then you have to use the magnification formula. M is equal to h dash by h, or which is also equal to minus v by u for mirror. Applying this, you can get the height of the image as minus 14 centimeter. Since it is minus, it is in negative, so image is real, inverted and enlarged in size. Now the last next we have question number 10 over there. 10 and 11. These are the last two questions from this chapter. Find the focal length of a lens of power 0 minus 0.2 diopter. What type of lens is this? In this question, power is given as minus 2.0 diopter. We have to find the focal length. So we know that focal length power f is equal to 1 by f. So we can write that focal length f is equal to 1 by p. 1 by p. So 1 divided by minus 2.0, which is equal to minus 0.5 cm. This is our focal length. Since it is negative, which type of lens it is? It is a concave lens. It is a concave lens. Next question. A doctor has prescribed a corrective lens of power plus 1.5 diopter. Power is plus 1.5 diopter. Find the focal length. Also, we have to find the focal length. Is prescribed lens diverging or converging? So, for focal length, f is equal to 1 by p, which is equal to 1 divided by 1.5. We'll remove the decimal. At the top, 2s are 3s are 2 by 3 we are getting. Okay, when you'll solve this one, you will get it in the form of decimal 0.6667 centimeter, something like that. But if you'll get it in positive value, you'll get that in positive value. And since you are getting a positive focal length, so the type of the lens is converging one. Converging. So with this few of the numericals which were given in your Ncert book, we have solved those numericals. I hope you have got the concept of the formulas. Remember that object distance u is always taken as negative. Always, whether it is a mirror or a lens, you have to take it as negative, and height of the object is always taken as positive. It is always taken as a positive. If the focal length is positive, then what type of mirror or lens it is? If the focal length is positive, then the mirror or the lens will be convex. But if it is negative, then the mirror or the lens will be concave in nature. So these things you have to keep in mind, and you have to clearly look at the question that whether it is a lens or a mirror. Then you have to use, if it is a lens, you have to use the lens formula, and if it is a mirror, you have to use the mirror formula, and accordingly you have to solve the questions. So I hope you all have understood the concepts of the formulas which are given in the chapter light reflection and refraction. In case if you don't know anything about the question, at least you should write the datas which are given in the question. Object distance is given, image distance is given, height of the object, image, focal length, magnification, whatever things which are given in the question, write down those things. Then think that which formula you have to use. Write the formula and then put the values. You'll definitely get the answer. So thank you for watching this tutorial. If you like it, then please click on the like button, share it with your friends, and don't forget to subscribe my channel. And if you have subscribed, then please click on the like button, on the notification, on the bell icon, so that whenever I will be uploading a new video, you'll get the notification for that. Thank you for watching.